You've probably heard the pitch, right? Just feed a ton of raw data into a machine learning algorithm and magic happens. But if you've ever tried it, you know that's not really how it works. Not even close.
So that raises a fundamental question. Why? Why can't these incredibly powerful models just figure it out on their own? What are they missing?
Well, by the end of this, you'll understand that crucial middle step, the one that transforms messy, raw data into the clean, high-octane fuel that models actually run on.
To get there, let's first look at the problem head-on. It all starts with the data itself. Think about a typical data set. It's usually a mix of everything. You've got text categories, like a person's education level, right next to small numbers for their age, and then these huge numbers for their salary. It's all just jumbled together.
And here's the core issue. Machine learning models don't think in terms of words or concepts. They operate in the world of math. At the end of the day, they really only speak one language: numbers.
So if our data and our models are speaking two different languages, we need to act as the translator. And that process of translation, of preparation, is our focus today.
The best analogy I've found for this is a chef in a kitchen. Your raw data, that's your pile of ingredients. The machine learning model is your fancy, high-tech oven. And all the prep work in between, the chopping, the seasoning, the mixing, that is feature engineering.
And it's true, isn't it? You can't just toss a whole potato and an unpeeled onion into that oven and hope for the best. The quality of the final meal depends almost entirely on the quality of the prep work.
So, let's give this prep work its proper name: feature engineering. It's the art and science of transforming raw data into features that actually represent the problem you're trying to solve. It's about making the data speak the model's language.
Okay, so we get the why. Now let's dig into the how with a couple of the most common techniques you'll see.
First up, what do we do with all that text data? We use something called categorical encoding. The name says it all. It's about converting those text categories into numbers the model can understand.
One of the most popular ways to do this is with one-hot encoding. So instead of a single column with the words red, blue, or green, we create a new column for each possible color. If an item is red, the red column gets a 1 and the others get a 0. Just like that, text becomes numbers.
All right, text is handled. But what about our numbers? Remember how age was a small number and salary was a huge one? That's also a problem.
See, when a model sees a number like 90,000 next to a number like 40, it can get biased. It might assume the bigger number's way more important just because of its scale. This can throw the entire learning process off balance.
So what do? We scale them. A technique like min-max scaling squishes all the values into a common range, say between 0 and 1. Now they're on an even playing field, and the model can compare them fairly.
This general idea is called feature scaling. Its only job is to make sure no feature shouts louder than the others just because its numbers are bigger. It's all about letting the information content shine through, not the magnitude.
So these are some foundational techniques. But why does this matter so much in the real world? What's the actual payoff?
Well, because great feature engineering isn't just about cleaning, it's also about creating. It's where you use your own knowledge to build better signals. For example, instead of giving a model "you're built and you're sold," you can create a new feature, House Age. That new feature is often way more predictive than the original two combined.
And this isn't just theoretical. In one case, a team improved their model's predictions for on-time deliveries just by creating a few clever new features like this. The results were pretty dramatic.
They saw an 8 percentage point jump in accuracy. Think about that. That's a huge real-world impact, and it didn't come from a fancier model. It came from smarter data preparation.
So if you take away one thing, it's this. Feature engineering is what turns raw, potentially confusing data into the powerful, predictive signals your model needs to learn effectively. I really like this quote. Feature engineering truly is the bridge between your data and your model. Without that bridge, the two can't communicate.
Now that we know how to create and prepare our features, the next logical question is, how do we choose the best ones? That's a process called feature selection, and we'll dive into it tomorrow.